Welcome to an exploration of a transformative journey in satellite imagery analysis. In this presentation, we unveil a pioneering approach to change detection that promises unprecedented accuracy. Our quest for precision begins with the fusion of two remarkable technologies: convolutional neural networks, CNNs, and generative adversarial networks, GANs. Together, they pave the way for transformative change detection. The technology stack forms the foundation of our revolution. Deep learning frameworks, such as TensorFlow and PyTorch, are our tools for change. Our success is rooted in synergy, not just in technology. We leverage GAN-based techniques to amplify data quality, transforming ordinary input into a powerful tool. Let's explore the satellite image classification process through a simplified flowchart. Data collection. Gather satellite images from sources like Sentinel-2 and LIS-4. Preprocessing. Apply radiometric and atmospheric corrections for data enhancement. Feature extraction. Utilize CNNs to extract relevant features from the images. Image classification. Use machine learning to classify images into categories. GAN-based enhancement. Employ GANs to enhance image quality and augment the data set. Post-processing. Refine results to ensure accuracy. Validation and accuracy assessment. Evaluate classification results using ground truth data. Application. Apply classified imagery to real-world uses such as urban planning, land management, and environmental monitoring. This process empowers decision-making in various domains through satellite imagery analysis. The heart of our project lies in its core components. CNNs extract rich features, while GANs enhance the quality of our imagery. In conclusion, we are on the brink of reshaping remote sensing and satellite imagery analysis. Thank you for joining us on this exploratory journey.